Hello there, Johnny Vanford here, Lorain County Community College's MEMS and Microelectronics Manufacturing Program and Merit Manufacturing Electronics and Rework Institute for Training. I'm here in the clean room with a new piece of equipment that we just got. I'm going to kind of wheel the USB camera around here so you can take a look at it. It's our brand new Keyence laser microscope is what we've got. We just got this in the other day. Here you can see me filming. That's some deception right there. Interesting camera on back here. So what I wanted to show you what to do is this is actually a laser profilometer. I wanted to give you a chance to see kind of what this is and how this works over here. So let me kind of get rid of some of this stuff that's over here. Okay, so the screen that you're looking at right now is what we use to make a measurement of something. First, I'm going to put something underneath the microscope here that we can actually see. So what I'm going to do is I'm going to bring the stage out. This is a live view of the microscope camera. I'm going to put a 2-inch silicon wafer on here that actually has some photolithography that's been developed onto it. Look at that. Can we find the Lorain County Community College logo? Look at this nice logo. You see what this is? I can click and drag on the screen and I'll even go down and look at this. The Microsystems Institute Education of MEMS degree, Training, Ohio, certification of the Microelectronics Institute. Man, this is an old screen. So what I want to do is kind of show you how to use this system. This system is very, very good at being able to capture the profiles of things in terms of what it does. And here's kind of the general way of how you do it. First thing you do is you're going to power it on using the power button on the side and make sure that the little computer is on as well, right? Start with actually, what you would do next is you would want to load the software. And the software that you'll be loading is actually this one right here, the VK-X3000 viewer system with that. That's actually what's showing as of right now. Then, once it origins, you have to do a little origin with it here. And you click and drag. I'm left clicking and dragging on the screen to find something to scan in. Let's see if we can find something. Oh, here we go. Look at this. Here's a scale of 5 microns, 10 microns, 25 micron lines, 50 micron lines, what appears to be a hair and a man that's sitting over here watching what we're doing for this here, right? So the way that this system works is it uses a complex series of lenses and laser systems to be able to scan in the heights of small features. Features as thin as photoresist, such as what you see on the screen right now, they put this into focus by hitting the auto focus button for this. There, the laser comes on real quick and tries to put this into focus. And I'm going to use the scroll wheel right here to put this remaining part of there into focus for this. So now I've got some focus at the 5x lens setting. If I go down to the 10x lens setting, it will mechanically adjust itself so that it comes down. Now I'm at the 10x lens setting for this. Here I can get the scroll wheel to put me a little bit more into focus with this so that I can get a better idea in terms of what this is. 5x and 10x is perfectly fine for doing things such as packages or solder joints or something like that, but photolithography, photoresist is actually pretty thin in terms of what that is. The 20x and the 50x are going to be the preferred lenses to be able to be used for this particular setup for this. So we're actually going to zoom into these little bars that are right here using the 20x lens. Oh, we got the 20x lens system right there. You can see the little fringes due to probably a little bit of some overexposure and whatnot maybe with that here. So that allows us to just get an image. That's the whole purpose of this. And actually, one of the things I can do with this part over here is I can register a navigation image. And here what it's going to do is it's going to take a whole bunch of images for this. I'm going to click the finish button. And now I've actually got a large picture of different spots that I am on the wafer for this. If I, for instance, want to click in a new spot over here, it'll take me to where that is if I want to look at the guy's face. Hey, how's it going over there, right? There's the guy. But this allows me to better get an idea of where something is, which is really handy if I've got like a very large area of surface of lots of small features, like most wafers are. All right, so now there's other options at the top for this here if I wanted to include a scale bar on what it is that I was working on, or I wanted to make a very short measurement of something along these lines. So let's try and do 2 points for this. I'm actually not so certain if this will work correctly. Here's 2 points right here and right here. And I'm going to kind of, yeah, that's about, I think, where that should be for that. It's about 10 microns going between there, because each one of these is, I believe, a 10 micron line with a 10 micron space. And that's pretty close towards where that is. I'll delete all of those guys in terms of where that is. So now we're going to go down to 50x next, which is really where the photolithography fun comes from. That's just any microscope tool can be able to adjust for this. I'm going to do a little autofocus, see if we can focus in on my photoresist. There we go. What a nice feature for that right there. All right, so now what I'm going to do is I'm going to go to the shape measurements tool feature. Now, this is the really cool part of how this system works for this. Focus variation for the scan mode will be for things that are using the 5x and 10x lenses. Laser confocal for the 20 and 50x lenses. Seems pretty simple enough. I'm going to start my measurement now. So now what it's going to do is it's going to use the laser to do a series of measurements on this tool. And so what it's doing right now is it's lifting the lenses very slowly and carefully around where the wafer is. You don't want to try and bump the table or anything like that. That would cause potentially some possible damages that could occur with this here. So we want to let it do its thing for a little bit here. And then you see the processing bar kind of in the lower window for this. And then voila, what we get in the end right here is an actual three-dimensional image. Probably doesn't look too three-dimensional as it is right now. We have to play around with it a little bit, right? So we're going to, for instance, change the, I like to do the laser and optical one right here to give me some color variation. One, like on the far right-hand side, that's just like a literal picture of what it is. This, though, gives me an idea of what certain colors are that are going to be on here. Now, I don't have a lot of strong features for this, right? So I'm going to actually raise this up a little bit so I can increase what some of these features actually look like. And here we can see we definitely have some heighted features. The blue represents kind of the lower area at about 1/2 micron, and this is up around 1.1 microns. And I think this photoresist is something in the range of like 5,000 or 6,000 angstroms, and that's about 5 or 6/10 of a micron, I think is where that is in its entirety. So now I've got some features, and I can get like in the basic idea. So the red at the top, that's where the photoresist is. That's at about 1 or 1.1. Blue is at the bottom. That's at about like 0.5 according to this. This is a relative scale, right? And so with that relative scale for that, I can subtract the bottom from top, and that gives me about a 0.6 in terms of where that is. But wouldn't it be nice if I actually had some other features to be able to kind of look as to where this is? If we do, so now we're going to go to the Analyze feature. I'm going to save this as photoresist on wafer for video. Right there, that's a good file save. And it's going to load up the multi-file analyzer at this point. This is the other really neat software that this comes with here. Here it's got the main image, an additional image, and a 3D image that's associated with that, and all of these really cool features that's up at the top part of this, right? The main one that I'm interested in is the profile feature. It measures the lengths, angles, height, and other properties of a cross-sectional profile. This is the really neat one, right? So I'm going to put the 3D image right here in a little bit better view. And I do like it to where I can get some height out of what I can see with this here, so that way I have a better idea in terms of how tall some of my features are. Maybe not that tall, right? So now, on the profile tool, I'm going to select 2 points. I'm going to select, click on 2 points. I need to select it to use it. And I'm going to select a point over here and a point over here. So now I've got a feature that has actually showed up as a cross-sectional profile under this part of it here. I'm going to hit the image fit button so that way it scans all the way across. Now this is basically a 2D cutaway in terms of what I've looked at. It's if I've dragged, it's almost like a contact profilometer, or it's like I've dragged a line across this and it's measuring how tall the features are. At the bottom, it's at about 0.6. At the top, it's at about 1.1. But I need to do a little bit of some corrections for this right here, correcting for basically, I know the bottom of this is actually 0. The machine doesn't really know that, but I know that. So I'm actually going to hit correct tilt. And then under correct tilt, what I'm going to put here is I'm going to go from one side of it all the way over to the other flat side. And I'm going to say all of that, that's actually one flat surface in terms of what that is. I hit OK at this point here. And then finally, I'm going to hit an image fit. Maybe a line fit. There we go. Right here. And actually, I'm going to do one more correction of the tilt. I may have hit the wrong thing for that one right here. And again, I'm still trying to learn how to use this this guy as well. So if I make occasional whoopses with this here, make sure you like, comment, and subscribe my way around with that. That's getting kind of close in terms of what that is, but it's kind of not close enough in terms of exactly what it is. I still have to do a little bit of some math involved with that here. Let's see if I can do maybe one more in terms of where this is. So let's do I don't want to zoom in like that much with that there. There we go. A nice line fit. All right, so line, we're going to go from here to, say, about here, right? Okay. And then here we're going to do a line fit. There we go. That's a little bit better for that, right? I can see here that if I wanted to do a point-to-point feature, I'm going to do one point to another. I'm going to do, say like the bottom of this line right here. Click on it to do a vertical distance for this. I'm going to do up here to all the way at the top part of this here. And check that out. I have a measurement right here of 0.447 micrometers to be able to give me the measurement that I need for that. Isn't that cool? So that's pretty neat to be able to see something like that there. I'm actually greatly impressed in terms of what that is. And this allows us to get profile features of our photolithography, of our any kind of wafer processing kind of stuff with that. It allows us to get features for our packaging, for our wire bonding and our die attach in terms of how's the thickness of the die, where's the epoxy going around the side, how tall are the wire bonds, how big are the wire bond thermosonic balls, or something as like our fillet. What is the angle of our fillet? Do we have a fillet on some of our parts? To get us actual profile features of what some of these are. And the best part is we're actually going to put this software in all the computers inside the lab, creating a very useful tool that students will be able to use to utilize profilometry features of things. So kind of cool stuff. All right, folks. Well, thank you very much for coming. This is Johnny Vanderford with the Lorain County Community College MEMS and Microelectronics Manufacturing Program, Merit Manufacturing Electronics and Rework Institute for Training. Folks, we'll see you around on the next one, okay? See you later. Bye-bye.